Hello, guys. Okay, so today we are going to start looking at how to differentiate products and quotients. So the goal of this lesson is to learn how to make use of a result known as the product rule in maths, which is used mostly when you want to differentiate either products or quotients. You see, but first let's understand what exactly is a product. So a product is simple two functions multiplying each other like that. While it's the quotient, on the other hand, it is just two functions which are dividing each other like that. So that's what we want to learn, how to differentiate things like that. So to differentiate or to learn how to differentiate things like that, we have a result which is known as the product rule. And the rule goes as follows. It says that if you want to find the derivative of a product of two functions g of x and h of x, then this is just the same as saying g of x dx of h of x plus h of x times d of dx of g of x, like that. So that's the result that we call the product rule. You see, so the fact that it's a product rule, it is most usually designed for handling products. But one of the things that you have to know is that there are some books which talk about a result known as the quotient rule again. But if you are to look at anything that is called a quotient, you will come to a realization that any quotient actually is a product. You see, because this can be written as gx times h of x to power negative 1. So what we call a quotient is a different version of a product. So which means I'm not going to discuss how to make use of the quotient rule. So if you want, you can learn it on your own, but you can tackle anything which is either a product or quotient by making use of the product rule. You see. So now again, as I say, these rules, they just carry messages or information that you just have to extract from them, and then you can forget about them. So the product rule is not something that you try and spend your whole day trying to memorize what exactly is it trying to say. So it's not important to do that. So what we're going to do now is I'm going to provide you with a demonstration as to how exactly do you make use of the product rule to find derivatives of products. You see, so let's look at a few examples. So an example that we're going to look at, it goes as follows. So if y is a product of x to the power 10 times the natural log of x to 6 minus 1, find dy dx. So how do we answer that one there? You see. So how we answer something like this, we proceed as follows. So first we want to find the derivative. So we want to find dy dx. So every time when you have a product, remember, it's always two functions involved. So if you are differentiating a product, this is a two-step process that goes as follows. So when you're given a product like this and you want to differentiate it, so the first thing that you do is you first take one of the functions, like for example, x10, and you keep it as it is. Then the next thing that you do is you take the function that is next to that one and differentiate it. You see. So now we differentiate this natural log of that. And we see that by differentiating, I differentiate first the argument, which will give me 6x5. Then I divide by the argument like that. Then the next thing now is I say plus. Now what I'm doing is I'm going to reverse their roles. So since now I was keeping this one stationary and differentiating the other one, now what I'm going to do, I'm going to keep that one stationary while I differentiate this one. So if I differentiate x to the power 10, I get 10x to the power 9. But there is a ln of x6 minus 1, which I was keeping stationary like that. So now you can simplify your answer by saying this is 6x to 15 over x6 minus 1 plus 10x9, then natural log of x6 minus 1. So we get that. So this is how you deal with products. So this is what that whole definition is all about. It's trying to tell you that it's a two-step process where you keep one on hold while you differentiate the other. And then next you repeat the process, but you change the one that you were holding last time and differentiate the other. So let's look at again another different example. So another different one, you can be given something like this. So they will say if y is equals to 3x2 minus 4 plus 1 to the power minus 8, and then e2 x squared plus 3. Find dy dx. So how do we deal with that? So to deal with that, this is how we proceed. So we want to find dy dx. So it's a product. So now you know the whole story. So the first thing is I keep the first term on hold. So I keep 3x to minus 4 plus 1 to minus 8 on hold, while I differentiate the other guy. So when I differentiate the other guy, I know that I start with the power first. So when I differentiate that power, I get 2x. So I bring that 2x down, and then I bring the exponent as it is, which is x squared plus 3. Then plus. Now, after when it comes to plus, now I reverse the roles. So now I keep this one stationary and differentiate the other. So if you look at the other, it is a function raised by a power. So I know the story. I bring first the power down. Then I differentiate inside. I get minus 12x to minus 5. And then I bring the function as it is, which is 3x to minus 4 plus 1 and reduce 1 from the power. I get that. And then we bring e to x squared plus 3. So you can simplify this further if you like, but I'm not gonna try and do that. But maybe to just give you a more simplified version, this will become 2x, 3x to minus 4 plus 1 to minus 8, and then plus 96 x to minus 5, 3x to minus 4 plus 1 to minus 9, and then e to x squared plus 3. So that's not the furthest simplification that you can do. As you can see, there is still a common factor that is there between these two terms, so you can still pull it out, but I'm not going to waste much time doing that. Otherwise, the whole point is for me to show you how to deal with products, and then the further simplifications, you can do that on your own. So this is how we differentiate a product of two functions. But already we mentioned that this thing works for both product and quotient. So let's see now how it works when we have a quotient. See, so you can be given something like this. So they say given f of x as a function which is equal to 3x to the power 4 over ln of x plus 1, find dy dx. So how can we find the solution here? So to find the solution here, first thing is we can agree that f of x that is given can be written as 3x4 then times ln of x plus 1 raised to power negative 1. So therefore, what is f prime x? So to find f prime x, first I know that I differentiate the first term while it's keeping the other thing stationary. So if I differentiate that, I get 12x cubed. Since I'm keeping that stationary, I just get this over ln that. And then now I keep this other term stationary. Then I differentiate the other one. So to differentiate this one, I see it's a function raised by a power. So I bring down the power. Then I differentiate the interior. So to differentiate the interior, this is a natural log. And when I'm differentiating a natural log, I start by its argument. So I differentiate the argument, I get 1, and then I divide by that very argument. Then afterwards, I take I bring my ln of x plus 1, but now the power is reduced by 1 and we get that. So this is how you deal with your quotients as well. So quotients are just products. So you don't have to learn the so-called quotient rule. The product rule is sufficient to handle any form of a quotient or product that you may come across. So yeah, that's it. We are going to end this one here today. So thanks for watching. See you next.